Hello, I'm Griffin. Thanks so much for joining me again. This is Mental Shortcuts, an intermediate warm-up on Brilliant.org. Let's get started. So what's this first problem saying? It says, can you quickly find 15% of 64? So I'm not even going to look at the hint. Let's mark it out for a second. This is what I would be doing. You know, you're at a restaurant. Your waiter is good. Not excellent, but pretty good. You want to give him a 15% tip on your bill, and your bill comes and it's $64. Well, how can you quickly figure out what 15% is and give him a fair tip? So what do? Well, first you can ask yourself, well, what is 10%? And 10% is just plain and simple, it is a building block. If you can find 10%, then you can pretty much figure out any of the easy ones. And 10%, all you have to do is move your decimal over. This is $64. You move your decimal over 1 point, and so 10% of 64 is 6.4, is $6.40 for this example. And this totally makes sense, because if 10% is 64, then what would 100% be? Well, multiply 10% by 10, you get 100. Multiply 6.4 times 10, you just move your decimal back over and you have 64. And so, yes, 6.4 is going to be 10%. So let's back up a little bit. So 6.4 is 10%. And then what's the last part? Well, we want to give 15%, not just 10. So where do we get this last 5%? Okay, we answered the question, what is 10%? Now let's answer the question, what is, and let's change colors here. What is 5%? Now 5% is also pretty easy to figure out, especially after we already know what 10% is. 5% is half of 10%. So to find 5%, we just cut 6.4 in half. We just divide it by 2. And what is 6.4 divided by 2? Well, that's 3.2. So we know 3.2 is 5%. And so lastly, how do we get the 15%? We just add the two together. 6.4 plus 3.2 is 9.6. We just add them two together and we get this answer. And this is a handy dandy little trick. I use it quite a bit whenever I go out. I think you'll definitely find it useful. Let's submit it. All right, next question. Clear our board. Which of these is equivalent to 7 times 64 plus 7 times 6? Well, again, this goes back to what is the definition of multiplication? Like how is it defined? How does it work? Well, 7 times anything, you're just adding a bunch of 7s. We just keep adding 7s. In this case, we added it 64 times. This was 64 times. And then what do we have? Well, we're adding some more 7s. This color is kind of hard to see. Let me go to a darker green. Now we're adding some more 7s. 7 plus 7. And this was 6 times. Nothing is different here, though. This is just one long string of 7s. So if we concatenate them and put them together, well, what do we have? Well, this was 7 64 times. This was 7 6 times. So all together, what do we have? We have 7 70 times. So this is just 7 times 70. So our answer here is going to be our second choice, 7 times 70. Correct. Awesome work. Next problem. Here we go. Again, I don't like these hints they give us. I'm going to try to mark them out. The hints give too much away. Using the perfect square identity, which of these is equivalent to 81 squared? All right, well, of course we know that 81 squared is just 81 times 81. But, lots of times this is tedious. You don't want to do it. How can we figure out a better way? And, I covered this up, but you can just look right through it. So what's the point of covering the hint? They gave it to us for a reason. What do we have? Well, they're saying a plus b squared equals a plus b times a plus b. So how are they wanting us to divide this up? Well, let's let our a equal to 80 and our b equal to 1. So what does that give us? Well, we have 80 plus 1, which is of course 81, times 80 plus 1. And then how do you multiply this out? It's what we call, what's often referred to as FOIL. You'll hear this term a lot in your math class. Oh, just FOIL the terms. And what this stands for is first, outer, inner, last. So we multiply our first terms together. So we have 80 times 80, so 80 squared. Then we have our outer terms, so 80 times 1. So this is plus 80. Our inner terms, 1 times 80, so plus another 80. And then our 1 times our 1, our last terms. And this would be plus 1 squared. So this is another thing we can do. And so what do we have? We have 80 squared plus 80 plus 80. So what is that? We have 80 squared plus 2 times 80 plus 1 squared. Does anything line up with this? And yes, it looks like C does. 80 squared, well, 8 times 8 is 64, and then add our 2 zeros from our 80 to get 6400, plus our 280, 2 times 80, and then plus our 1. It is not A because this is a minus sign. Everything is being added here. So our answer is C. Excellent. Next problem. Using the difference of two squares identity, which of these is equivalent to 5.7 times 6.3? So this is interesting. This is interesting. So how can this be useful? And I'm not gonna lie, this little trick is actually new to me. So what can we do here? I'm thinking, so our middle terms would cancel. So what do we have? We could have a let's try some things out. Let's just start writing things down and see what works, what doesn't work, what are we doing. If we have an a plus b, just similarly to the last problem, we could have a 5 plus a 0.7. And then the last problem, we were subtracting something now. So what would we be subtracting? We could maybe subtract if we had 6 and then minus a negative 3, but that doesn't make too much sense. Oh, you know what? What if we do, here, this is what I'm thinking. If we do 6 minus 0.3, what do we have? Well, we have our 5.7. Here, this second term is actually our 5.7 term. 6 minus 0.3 is 5.7. And let's fix this one over here. Let's do some erasing. So this is not our 5.7 term. What should we put here? We're adding two things. This is actually 6 plus 0.3. And now this works. We have 6 plus 0.3, which is 6.3, and 6 minus 0.3, which is 5.7. Okay, so now let's distribute. Let's FOIL it. And so we have our first, which is 36. 6 squared is 36. It looks like they have 6 squared in our answer choice, so I'm going to also write 6 squared down here. And then what's great about a plus and a minus is our center term is going to end up canceling. So we have our first outer, so 6 minus 0.3, 6 times negative 0.3. That's going to be minus 6 times 0.3. And then this term cancels it out. The 0.3 times the 6, this is plus 0.3 times the 6. And so I hope you see that we're subtracting it and then adding it, so this simply cancels. So we don't even need to write this down really. And then what do we lastly have? We have 0.3 times 0.3, and it's being subtracted, and so we have minus 0.3 squared. So 6 squared minus 0.3 squared will be our answer. So our answer here is B. So this one was a little bit tricky in the beginning, at least it was for me. So let's recap for a second. Let's submit it and then recap. So we got the answer right, excellent. So what did we do? Again, we looked at our numbers. We see that there is some symmetry here. There's some symmetry around the number 6, and we can actually end up using this hint, a squared minus b squared, to write, well, 6 plus 0.3 times 6 minus 0.3. And let's not forget our parentheses to make things easier. And whenever we FOIL this out, our middle two terms cancel, and we're left with our outer terms multiplied against each other and our middle terms multiplied against each other. And that's how we got B as our answer. Excellent. Let's go to the next problem. Interesting, 35 times 28, and then they even, this problem's pretty much solved. This is a very, very interesting way to solve two-digit multiplication problems. We kind of put it in a little square here. This reminds me of biology class when I was making those Punnett squares. But we have our 30 and our 5. Oops. We have our 30 and our 5, and our 20 and our 8, and they just multiplied all of these. And this is something you can totally do for multiplication. If this makes it easier for you, totally use this method. This is excellent. And after you have your squares filled out, you just add them all up. 600 plus 100 is 700. 700. 240 plus 40 is 280. And then you add them up. 0, 8, 9. So our answer here should be 980. Let me type it in. 980. Enter. Awesome. Excellent work. Excellent work. These were some great little mental math shortcuts. I hope you learned something interesting in this. Please let me know what was useful and what wasn't. I look forward to hearing back from you guys. Please subscribe. Until next time.